Let's see. Okay. Welcome. Fourth week, and we are getting a little bit quantitative part today. Well, I promised that there will be excuse me, basically no prerequisite except high school algebra and Microsoft Excel. Well, today lecture will be in two different parts. Well, at least the PowerPoint slide are two different parts. And let's see if I can cover everything in 1 week or not. Today's lecture is a little bit heavy. Well, today we are going to learn what they call input-output model. Input-output model has been awarded a Nobel Prize in Economics in 1973. Dr. Vasily Leontiev got the Nobel Prize. So, I don't know, you might have already heard about this or not, but if you haven't learned any economic theories which got the Nobel Prize in Economics, today is a day. You will learn it. I have taught the same course previously at the hotel school somewhere in New York, and also I have been teaching this in several seminars, and I have been teaching this in some graduate courses. So I think you can do it. It is tough, but let's start from the good thing. If you know, or if you learn what you will learn today, honestly, you not only know the theory which got the Nobel Prize in Economics, but I will lift you up to the level that you can use it. Yes. So you have fun. So today is a day to develop your hard head, not the soft heart. Okay. Basic algebra quiz. Yeah, simply because, I really want to make sure that you understand the basic. X raised to the power of n, all right? When was the last time you have seen something like this? I know some of you may be more, I don't know, quantitative or love mathematics, so you've been seeing these things every day. So for those people, I'm sorry, I'm going to bore you to death in a sense, very sorry. But how about this? 2 squared and 2 cubed. What's the answer for 2 squared? I think everybody got it right. Yes? 4. How about 2 cubed? 2 raised to the power of 3. How much it would be? From my experience, this is a question I start to hear 2 answers. One says 8, and somebody else says, that's 6? Which is correct, 6 or 8? Yeah, 8. Because it's basically 2 times 2 times 2. 8, right? All right, ready for the next one. How about these? 2 raised to the power of -1. Anybody know the answer? Or anybody have enough confidence to answer this? If you do, I'm sorry, today's lecture may be boring, at least first half. How about this little bit yucky one? Bracket, parenthesis, I minus a, end of the parenthesis, raised to the power of -1. Oh my God, what to do? Well, let's start from the first one. Well, I wish I had I don't know if this works. Well, let's try. Yeah, 2 raised to the power of -1, or 2 inverse. Well, I said the answer. This will become something like this. 1. See this? 1 over 2 raised to the power of 1. So it becomes 1 over 2. Ah, not that bad, yes? So 2 raised to the power of -1 becomes 1 over 2. So when you see minus, basically put the 1 on the numerator and put this number to the denominator and take this minus out. So this. Now, two times, sorry for this, I don't know if you can see it, but 2 times 1/2. What's the answer? 2 times 1/2. What would be the answer? Yes. I think like 2/3 of people answered. I can hear that. Right? 2 times 1/2 becomes 1. Yes? So what's the relationship here and here? 1/2 is the inverse of 2. So 2 multiplied by its own inverse will result in 1. Yes? Basically, this math is going to be very important today. So, if you understand this, I minus a, whatever it is, raised to the power of -1 would be 1 numerator, and put that whole stuff as a denominator and take the minus out. So I minus a raised to the power of 1, so it will be 1 over bracket I minus a. Got it? This is important. And that's why I say high school algebra. I don't know if this is high school or middle school. But this will be the key for you to navigate through today's course, okay? My keyboard doesn't work. Hi, mouse. Does it work? Okay. So, this is absolute minimum to understand the IO model, which earned Nobel Prize in economics. Excuse me. Yes, it looks painful, but it's just like dental treatment. Before you have your dental treatment, you get this little injection. Oh, that's a little bit of pain, Oh, yes, but once you have this injection, your gum is numbed and you don't feel any pain after that. This is exactly just like that. Please, this may look painful. It may have a small pain. Yes, but once you have that injection or understanding of this, you will have no pain after that. All right, next. All right. Input-output model. Yes. Here is the equation. Inter-industry needs plus final demand equal total output. What is total output? Let's say if you have a factory everything it comes out from the factory is total output. All right? So total output, everything comes out from the factory, which is the total output, consists of two things. One is called inter-industry needs. The other one is called final demand. Again, total output equal inter-industry needs plus final demand. You see the color? Blue, red, green. All right. If you take an example, you will understand. Oh, my keyboard doesn't work today. Oh, yes, it did. Some kind of radio. All right. Let's pick up the case of tire factory. Firestone, Bridgestone, Michelin, Goodyear, whatever. As a tire factory, you produce tires, yes? And some tires will be shipped to you and I. Do you need a tire? Oh, yes. Do I need a tire? Yeah, sometimes. Actually, I'm in need of one set of 4 tires now. Okay. So, when the tire factory makes tires, definitely some part goes to consumers, you and I. Red, yes? And some other part goes to car company, for example, Ford, for example, Nissan, or Honda, so that they will put those tires in a new car. They may need 4, at least maybe 5 of them for each one car. And they will sell the car as a new car to the consumer. So, when the car company purchases tire, it is not for their own usage, but they needed tire as a part, necessary part of their product they are making. Understand? This is an important part. Factory makes tires. Some tire goes directly to the consumption by the consumers. You and I purchase tires. Or some tire goes straight to the Honda Motor Factory or Ford Motor Factory, so that Ford Motor Company will make another Taurus, or Honda makes another Accord. Understand? So even though the tire company makes tires, it basically goes to 2 different needs. One is the inter-industry needs, which is required parts for their production. The other part is going straight to the consumers. How about the computer hard disk factory? The computer hard disk factory, Hitachi, Fujitsu, Seagate. These companies make computer hard disk. Who purchases this hard disk? Of course, you and I sometimes open up this desktop and change the old 80 gigabyte hard disk replaced with 1 terabyte. Yes. So we buy hard disk from the computer hard disk factory. Yes. Where at the same time, computer hard disk factory sells hard disk to Hewlett Packard for their computers, so that they will use that as a necessary ingredient, part of their finished product as desktop computers. Got it? So when you make a computer hard disk, it goes to basically 2 kinds. One directly to the consumer, the other one goes to other industrial production, other companies. Very important. Now, airlines. Airlines. There are some seats which goes directly to guests, Continental.com, United.com, something like that, Delta.com. So you buy the ticket, right? But sometimes airline ticket goes to wholesalers. Some travel agencies purchases 200 tickets altogether, and they distribute separately. Because if they buy bulk, the price is cheaper, you know. Or sometimes, for example, the case I know, banks sometimes create like investment seminars, and they invite very affluent people from other parts of the world, and part of that whole trip is the flight expense. So the finance companies or banks purchases all these parts combined together, and as a final product they sell to somebody. Here is ultimate investment opportunities, and so on and so on. It's a tour. When you travel to some other countries, I don't know, for example, want to see the Victoria Falls, and you join the tour. These tour operators, maybe based, for example, based in London, UK, or New York, you pay one fee, yes, $5,000, everything included, and transportation included. So from New York to Zimbabwe, or from London to Zimbabwe, that flight ticket would be the part of the whole tour. So in this case, airlines sold the ticket not directly to the consumers, but to the wholesaler. Got it? So even in the tourism industry, this applies. My keyboard. All right. Yes. So now you have seen enough, hopefully. Total output consisting of inter-industry needs and the final demand. Inter-industry needs, let's define it as AX. X, as you see, the first line is a total output. So let's put the total output as X. Inter-industry needs, let's put it as AX, whereas A is bigger than or larger than 0, but smaller than 1, something between 0 and 1. Okay. And the final demand, we put Y. Okay? So Y is the final demand. What was the inter-industry needs and final demand? If you forgot, go back one slide. I will give you explanation again. I never get angry because I'm a Cyberman, just rewind, push, and let me speak again. Doesn't work. Okay, another thing we have to learn. I. Sounds like I. That's in metrics definition, it's called identity metrics. Identity metrics works just like number 1. 5 times 1 equals 5. So some kind of metrics multiplied by identity matrix just gives you exactly the first original matrix. So it's just like number 1. All right. So do you remember AX? Inter-industry needs plus Y. What was that? Final demands equals X, total output. Remember? You need example? The hard disk, which Fujitsu set it to their computer, plus the hard disk Fujitsu sells to you and I, equals the total amount of hard disk that Fujitsu factory created. AX plus Y equals X. Is this okay? Or tire factories. Okay, Firestone made some tires, set it to Ford Motors, that's AX, inter-industry needs, plus some tire goes to consumers, you and I, Y, okay? So added together, that's the total amount of tires produced by this Firestone factory. Inter-industry needs plus final demand equal total output. Now, from equation 1 to to equation 2, what did I do? Ax plus y equal x. Equation 2 is y equal x minus ax. What did I do? From 1 to 2. Yes. Like one third of you told me the answer. Just move the ax. Look at the equation 1. Just move the ax from left side of the equation to the right side of the equation so that the sign changes from plus to minus. So left side of the equation remains only y. So y equal x, and ax goes to the right side, it will have a minus. So it will be y equal x minus ax. Here we go, the equation number 2, right? Next, from equation 2 to equation 3, what did I do? Again, I works like just number 1, all right? That's right. In equation 2, I see 2x's on the right side of the equal, yes? So, using that x part, let's say 1 minus a, or I minus a. Does that hold? That's what I did from 2 to 3. If you look at equation 3, right side of the equal, I minus a x, multiplied by I times x, then minus a times x. So it will be x minus x, right? That's what I did from 2 to 3. Yeah. I'm getting hot. Excuse me. Now, what did I do in equation 4? The theory of the equation, if you do the same thing to both sides, right side and left side, exactly the same thing, the equation still holds, yes? So what did I do from 3 to 4? It appears that I divided both sides of the equation by I minus a bracket, right? That's what I did for number 4. All right, now. Oops, samurai. What is he doing? I see. See, from 4 to 5, what happened? 4 is the green one, and the 5, the top equation. What did I do? I think I have imported some samurai to do the work, yes? If you look at the right side of the equation of number 4, right side of the equation read as I minus ax over I minus a. So what can you do? That's right. Cut them out. So that if you do that, right side of the equation is cleared of I minus a, and it will only be x. Therefore, you have the first line equation of the number 5. Y over I minus a equal x. Right? And here, do you remember that we covered with pen and paper? This first equation in 5, can it be rewritten as a second equation? If y over I minus a equal x, can I write it in a way that I minus a inverse, raised to minus 1, or I can read it as inverse y equal x, right? So, now I introduce new thing called delta. It looks like a triangle. This triangle, you read it as delta, like a hairline. Delta, right? Delta, when you read it, in normal language, you read it as change in, change in, So, I minus a inverse delta y, I minus a inverse multiplied by change in y, change in final demand equals delta x. So how do I read it? Change in total output. Yes? You got it. That's it. Equation, that's it. How do we use it? Let's start. Oh, this is a little bit of exercise. Let's, I know some of you have, brain saying that, no, I don't like this X, Y stuff. Just put the real number so that I can understand better. Yes, your wish is served. Let's assume that total output is $10 and final demand is $5. Proportion of inter-industry needs in the total output A, let's put it 0.5. It's super simplified version, okay? One by one. Okay, so I is called identity matrix. I matrix, identity matrix. And it works just like a number 1. All right, so start from AX plus Y equal X. A is 0.5, and X is 10, yes? Y equals 5. So what is this X? Right, by definition 10. Does this equation hold? So it seems, because AX is 0.5 times 10, so it's 5. Y is 5, and X is 10, so 5 plus 5 equals 10. Aha. It's like elementary school kind of summation. But it can be, how do you call it, intimidating if you see it in this way. But if you put some numbers, it's not that bad. Now, from 1 to 2, what did I do? This is just a review. Right, I changed the AX from the left side of the equal to the right side of the equal, yes? So Y equals X minus X. What was Y? Y, we put it as 5 equals X. What is that? 10 minus AX. A is 0.5, X is 10. So Y, 5 equals 10 minus 0.5 times 10, which means 5 equals 10 minus 5. Does it hold? Thank you. Good. Equation 3. Y is 5 equals I minus A times X. What is I? 1. What is A? 0.5. So 1 minus 0.5 is 0.5. 0.5 times X, 10, is 5. So 5 equals 0.5 times 10. Equation hold. Well, I'm getting a little bit tired, so you can just continue that, and you can see by yourself that equation hold. Very good. Now, welcome to the input-output. How much time did I spend? Oh, pretty fine. All right. Now, let's put input-output in action. In order to make it simplified so that everybody would understand, please allow me to simplify the world. The world consists of only 3 industries. What are they? Agriculture, manufacturing, and services. Yeah, that's about right. Agriculture, manufacturing, and services. So 3 industries. All right. So you see, agriculture, manufacturing, and services, that name comes in full on the left side of your table, and also on the top, there's abbreviation, agriculture, manufacturing, and services. Good. Let's see something else. Value added, lower left side, you see the word says value added. What is this? It's a labor, capital, these kind of things. We'll go into details when we learn social accounting metrics. But at this moment, value added, that's a labor and capital. Very important, labor and capital. Final demand. Do you remember what is final demand? That's right. When you buy a tire straight from the Firestone, or when you buy a hard disk straight from Fujitsu, 1 terabyte or something, that's your final demand. So FD, final demand. Where is it? Upper right side. Okay, you see the column? That's final demand. Final demand, what is it? Indeed. It is Well, it consists of consumption by household, government, etc. But at this moment, to simplify, final demand is something you buy from the industry. Yeah, that's a very simplified version, but they do hold for a while. So final demand is the consumption by household. Good. Now, how to read this table? Sectors, industrial sectors on the row, left side of the matrix, agriculture, manufacturing, services, on the row, left side of the matrix, produces goods and services. Sectors on the column, upper side of the matrix, received goods and services from other industry. So, goods and services moves this way, as you see in the big arrow, all right, this way. Let's put the numbers, then you may understand it a little better. Yeah, this is how the goods and services moves. That's right, all right. So, I put some numbers. Agriculture, if you look at agriculture column, AG column, 1, 1, 2, 6, 10. MNF, manufacturing column, 2, 3, 2, 3, 10. Service sector, 1, 2, 4, 13, 20. Yes? Good. Now. Oh, I see. Okay. Maybe before that, I would explain what are those numbers. If you look at the input-output table, yes, how to read it. Let's see the first one, agriculture row intersects with agriculture column. You see the number 1. What does it mean? Agricultural sector's output was purchased by agricultural sector for the price of 1. I don't know, this is 1 million or 1 billion, but for the unit of 1. So, the agricultural good moved from agricultural sector to the agricultural sector this way, yes? When the goods and services moves this way, exactly on the opposite side, exactly 180 degree different, what do you think would move? Very important question. Before I tell you the answer, let's try. Any of you get the answer right? Let me repeat the question because it's very important. When the goods and services moves from here to this way, what do you think would move exactly in opposite way in return? My gut feeling is about 1/4 of the people spoke. About half of the people have some kind of ideas, but too shy to speak up. Good. Money. When the goods and services moves in one direction, always the payment moves on the other side. Right? So, continue. Let's look at this. Services row intersects with agricultural column. You see number 2. What does it mean? This means that service sector provided certain kind of, goods or services to the agricultural sector, and the agricultural sector in return paid $2 or $2 million or $2 billion in return for that goods and services. Can you explain? Let's see. Manufacturing and services. Let's say manufacturing row intersect with service column, and I see number 2. How do you explain? Right. Manufacturing sector sold goods and services to the service sector, and service sector in return paid something to the manufacturing sector for the amount of 2. Yes. Goods and services move this way. In exchange, the money moves the opposite way. That's how you read input-output table. God, I'm lucky to do this video stuff, because if this is complete online, click this link and you read my explanation, this can be boring like a death, yes? Well, It may be already boring, but at least you can see what's going on. All right. So now, out of the input-output table, let's take that pink part out. Just extract that pink part, so that now we have 1, 2, 3, 4, 5 rows and 3 columns, 5 by 3. Yes? So we took out the industry column. Now, what do we do next? We will standardize this table. What do we mean standardize? Standardize means that take each element in the table, divide it by the column sum. What is the column sum? Why is the column sum? You add each numbers in the column, and the bottom number is the summation of all the numbers above. So 1, 2, 3, 4. Here we go. If you look at the agriculture sector, you see the number 1, 1, 2, 6. Yes? Add the number 1, 1, 2, 6. How much it would be? 10. That's why you have 10 in the bottom. Yes? Good. So actually, that summation is called total input. But at this moment, what I want you to do is to standardize. How to standardize? Take each element, divide it by the column sum. So in this case, 1 divided by 10. One divided by 10, what you will get? 0.1, right? Now, take 0.1 and put it back to exactly the original positions in input-output. You have to create a separate table. Looks exactly similar, but each ingredients, each element standardized. How do you standardize? Take that, divide it by the column sum. Do the same. Do the same for, do the same, this divided by 10 is 0.1. This 1 divided by 10 is 0.1. 2 divided by 10 is 0.2. 6 divided by 10 is 0.6. 1 divided by, oh, that's right. 10 divided by 10 becomes 1. So you will basically have these kind of calculation, yes? Let's see, what's next? So now you have standardized inter-industry transactions. So you had the low numbers, and now you standardized. So you have a standardized number, right? Then, the next thing is, take only that inter-industry part. I mean, industry exchanging goods and services with the other industry. So it will be a 3 by 3 matrix. 3 rows, 3 columns. When the number of rows and number of columns are same, we call it also square matrix. So A matrix has the shape of square matrix. In this case, it's 3 by 3. Yes? And once you standardize it and extract only the inter-industry part, it is called A matrix. A matrix. Very good. Let's go some more. Oh, this one is a little bit different explanation, but maybe at this moment you don't have to worry about it. Okay. Oh, hold on. How do I go back? Well, this is a part which is a little bit advanced. Oh. So maybe I will pass it at this time, or you can come back later, and I may come back later. Let's do a little bit of another basic algebra quiz. Welcome back. How about basic metric operations? All right. I know some of you says, oh my God, isn't this supposed to be a fun class? I told you, today is a day that I want to develop your hard head. If you have this theory mastered 60, 70 years ago, you could have been the man who received Nobel Prize in economics. But you're born in a little bit later. Okay, so basic matrix operations. I don't know how many of you have taken matrix computation, but if matrix B looks like A, B, C, D, matrix C looks like E, F, G, H, how do you do the calculation of matrix B plus C? How about B minus C? How about matrix L, M, N, O, but you have a K as a scalar. All right, here we go. Oh. So that one you don't have to answer, but I just wanted to ask you. That's it. So third question. Ooh, this is yucky. Same thing, just like one slide ago. When the matrix B is A, B, C, D, matrix C is E, F, G, H, how do you calculate matrix B times C? Yeah, this is the answer. But I guess if I do it in this regular class, I will eliminate some, no, don't be eliminated. I want everybody to stay in this class. Don't worry. If I do this in a regular class, I think it will alienate many people. So I have another way of doing it. Oh, what happened? Oh, there's another question, so let's try. What did I say? Oh, I see. All right. How about this? Inverse matrix. How do you calculate inverse matrix? If, the same thing, matrix B consists of A, B, C, D, what is B inverse? B inverse can be calculated. Excuse me. I'm yawning, so you must be yawning like 10 times more. So B inverse would be 1 over AD minus BC multiplied by position change. D and A is swapped. So D is over there, A is down there, and the B and C sign became different. If B and C was plus, now it becomes minus. That's how you calculate inverse matrix. Oh my God, yes? So I know, even though I'm not seeing your faces, because of my experience, I'm an old man, I know you have a little bit of headache on the other side of the computer screen. Well, this is just to fulfill some of your curiosity about how to calculate the inverse of matrix, which is a minimum 2 by 2 by head and hands. If you think this is horrible, I have a wonderful solution and proposal. Let's use Excel. To solve assignment 1, you have to calculate 15 by 15 matrix. That is not an easy task by head, paper, and hands. I would say that is just purely impossible. So, we must learn how to use Excel. Don't worry, I'll take care. All right? Let's see. Oh, that's the end of the part 1. Lucky you. And, my God, here's part 2. How many slides? Oh, not too bad. Yes, okay, so let's go on. All right, so matrix operation basic. Let's see, matrix A is 1, 3, 1, 2. Matrix B is 2, 3, 4, 2. Let's see the small square matrix of 2 by 2. How do we calculate A plus B? How do we calculate A minus B? If I show you the answer for A plus B and A minus B, it's almost like you're going to say to me, are you insulting my intelligence? Let me see. Oh, I don't have an answer, so I have to do it in front of you. Fine. So 1, 3, 1, 2 plus 2, 3, 4, 2 equals, can you see this? It's very simple. First you do 1 plus 2, 1 plus 2, yes, then 3 plus 3, then 1 plus 4, then 2 plus 2. So it will be what? 3, 6, 5, 4. That's how you do. Ha! Not bad at all. It may look scary, but not that bad. Next, A minus B. Guess what? Just as easy. 1 minus 2 is minus 1. 3 minus 3 is 0. 1 minus 4 is minus 3. 2 minus 2 equals 0. That's the answer. A times B will be a little bit challenging, and I don't think I was supposed to do that right here. So let's see. Where is the slide? Okay. Matrix multiplication. How do we do it? Look, if the matrix A consists of A, B, C, D, and B consists of E, F, G, H, A times B has to be calculated as this way. Okay, here the mouse. So let's see. A times E plus B times G. AE plus BG. Again. A times E plus B times Z becomes upper left. Then, next one, A times F, B times H. Add together will be here. Next one is C times E plus D times G, right here. Next one, C times F plus D times H is this one. Whew. That's certain kind of algorithm, but if you think this is horrible, yeah, it is. No wonder tourism people do not want to teach this. By the way, interesting thing. I went to a research conference recently, and there were like 300 papers. There was only one paper. I mean, graduate conference, graduate student, PhD student. I'm sorry, PhD student and a master student. There was only one research paper using this method. Maybe people think this is too hard, or it's a little bit complicated. So people don't necessarily follow this. But because of that, what's happening now is tourism and hospitality schools are way behind about economic impact of tourism topic, whereas organizations such as World Bank, OECD, United Nations, World Tourism Organization, all those institutions, as well as government, central government of Japan, China, South Korea, France, Sweden, Finland, and also African countries, South Africa, Egypt, Saudi Arabia. All these countries are very much interested in this as a government. But we are not teaching, at least in North America, including Canada and the US. This is the only course being taught at hospitality and tourism schools. Surprise, surprise. So it may be a little bit difficult, but let's put it the other way. If you get this, my God, you know certain things that only a few small number of students know about it. Does it matter? Yes, it does matter. If you have any interest in the future to work for those organizations, either government or World Bank, World Tourism Organization, and so on, or just simply interested in economic development of local community using the economic power of tourism. Let's go on. So now, 2 multiplied by n, what is that? We have done 2 squared, 2 cubed. How about 2 raised to the power of minus 1? How about 2 raised to the power of minus 3? Right? Oh, what happened? Oh, I forgot to take that out. Okay, 2 raised to the power of minus 1 is 1 over 2. 2 raised to the power of minus 3 would be 1 over 2 times 2 times 2, which equals 1 over 8. Huh. I didn't have an answer, but I think I answered correctly. So, inverse. What was that, first of all? In mathematics, the multiplicative inverse of a number x denoted 1 over x, or x raised to the power of minus 1, is a number which, when multiplied by x, yield 1. The multiplicative inverse of x is also called the reciprocal of x. So 2 and 1/2, 5 and 1/5, 10 and 1/10, x and 1 over x. These are all, relationship showing, the original number and its inverse. If you multiply the original number by its inverse, what's the answer? Do all these 4 in your head. Simple, isn't it? Right. Good. Inverse of matrix, yeah, fine. I think if I explain about this, you may not get it. The best thing is, you look at the PowerPoint slide, take pen and paper, just think, just concentrate and do this. Okay. Well, exercise time. Did I have that? Oh, this is the last slide of today. Ha, lucky you. All right, so calculate inverse. Let's see, a raised to the power of minus 1. If a matrix A is this, what would be the inverse of this? Then multiply A by its inverse. What do you get as I matrix? Multiply A matrix by the result, 3. Should I do this now? No, maybe I will do the separate ones. Okay. This was the end. Okay. So, I don't remember exactly how many minutes I have been speaking, but it could have been a little bit intensive because today we talked about a lot of numbers and a lot of equations. I am very sorry, but again, I told you this is just like a little bit of injection before you go to the before the dentist starts the major operation. Once you understand this, there will be no more pain. You may be saying, "Oh my God, that injection was so painful." No, it's not that bad. And I will guide you very soon to use Excel for this. However, please, it is based on my experience. Before you just start playing with Excel, you have to do at least 2 by 2 matrix calculation by hand. That would really help you to understand this. Okay? Thank you. And please, if you have any question, put your question on the discussion board and so on, so on. Happy to help you. I really want you to learn this. Thank you. And